Let's talk about Chapter 5. Chapter 5 is called Probability. Every statistics book has a chapter on probability. And really the reason is that the statistics is based upon the laws of probability. And now the book defines probability in a very simplistic way on page 178. It says a probability is a number between 0 and 1 that tells us how often an event occurs. So what I want you to think about is that a probability is just a number that's between 0 and 1, but it's also between 0% and 100%. So think about this. The probability that the sun's going to rise tomorrow is as certain as anything we have. And so that probability is 100%. 100% chance that the sun will rise tomorrow. If it doesn't, well, we won't be here long, will we? But it makes no sense to talk about a probability that's greater than 100%. 110% probability is meaningless. Here's another one. What's the probability that you or I could go out and run a mile in less than 3 minutes? No one's ever done that or come close, so that probability is 0 or 0%. So to talk about a negative probability also makes no sense whatsoever. So, but probability is how we measure the chance that something will happen. There are 3 kinds of probabilities. I think I might have mentioned this before in an earlier chapter, but let me go over it again. 3 kinds of probabilities. There's a theoretical probability. For example, if I'm flipping a coin, I know theoretically there's a 50% chance that I'm going to get heads or 50% chance I'm going to get tails. If I roll 2 dice, the chance of rolling 2 ones is 1 chance out of 36. That's a theoretical probability. So theoretical probabilities can be measured from some kind of mathematical law or physical law. Most of the time we deal in empirical probabilities. Empirical means by observation. And so we calculate probabilities based upon observation. When we take samples and do statistics on it, we're measuring empirical probabilities most of the time. And a third type of probability is called subjective probability. And subjective is you might think of it as an educated guess. For example, when the weatherman on TV says there's a 70% chance of snow tomorrow, he's just looking at weather patterns and he's just 70% sure there's going to be snow. Other than that, there's no real science to it. He's just looking at patterns. That's subjective. It's not based upon any kind of physical law. So, well, as it turns out, what do we do with probabilities and statistics other than calculate? Well, the way the data comes to us, the shape of the data tells us about the probability laws involved. So I'll elaborate on that as we move on. The book has a little bit about calculating probabilities. I don't really like to go into that. But the first distribution they talk about is called the binomial distribution. So let me say this. If you were to flip 4 coins, or think about this. What about a family with 4 children? If there's an equal probability of a girl or boy being born, and then the number of boys or girls in a 4-children family would obey the same laws as flipping a coin and measuring heads or tails. So let me write those probabilities out. So let's do the coin flip. Let's flip 4 coins. So number of heads, and we can have 4 heads out of 4, 3, 2, 1, or 0. And probability. Now, it turns out the probability of getting 4 heads is 1 chance out of 16. 1 out of 16. And then for 3 heads, it turns out it's 4 out of 16. 2 heads and 2 tails is 6 out of 16. 1 head is 4 out of 16, and 0 heads is 1 out of 16. So the reason for these numbers, we explore that, say, in our finite math course, and don't like to make it a big emphasis in this course at all. So I'm just asking you to take my word for it on this example here. But if you add up all these probabilities, add up these fractions, it comes out to exactly 100%. We call that the sample space. The total of the sample space is 100%. Alright, so now if I were to plot this out on a graph called a histogram, so let's call this number of heads 0, 1, 2, 3, 4. And let's see, 1, 2, 3, 4, 5, 6. This is probability. I'll abbreviate that. So I have 1 out of 16, 2 out of 16, and so on up to 6 out of 16. The graph of this probability distribution is going to look like this. And so 4 chances out of 16 for 1 head. 6 chances for 2 heads, 2 tails out of 16. And you see it's very symmetrical. Alright, so this kind of distribution is called a binomial distribution. The longer term would be binomial probability distribution. Probability distribution is a function, is called a PDF. Anyway, what do you notice about this pattern? Well, it's clustered in the center and tapered off at the ends. It may remind you of, in a sort of a crude coarse sense, the bell curve, which we're going to get into. But a binomial distribution is one in which there are 2 outcomes you're measuring. In this case, it's heads or tails. It could be male or female. It could be yes or no. It could be vote Democrat or vote Republican. Those are binomial distributions. You'll come to know them in this course as percent problems or proportion problems. And we're going to run into those starting in chapter 6 and 7.